All right. So our next speaker is a developer experience engineer from Netlify. His name is Ekene. When he's not working on things or doing Jamstack things, he loves teaching and learning stuff. Now, without further ado, I'd like to bring Kenny to the stage. Welcome, Kenny. How are you? Sorry, I think your internet was a little bit shaky there. How are you, Kenny? Or Ekene? Yeah, sorry, I think I'm calling you Kenny because of your Twitter. Yes.
Yeah, so much about personal branding there.
Yes, I can clearly see that. Yes.
Yeah, it's
All
fine.
right.
My name is Ekene Eze. I'm also Kenny, so thank you for having me.
All right. Are you ready to share your presentation?
Yes.
Great. Let's wait. All right. Adding it to the stream, and the floor is all yours.
All right. Thank you, everyone, for having me. Once again, my name is Ekene Eze, and you can call me Kenny. I'm a developer experience engineer at Netlify, and I'm super happy to be speaking with everyone today. Before I go further, I'd like to plead with everyone to bear with me. I'm currently in a low internet connectivity location, so there might be a little bit of back and forth and lags with my internet. So bear with me. I'll try and work with the event organizers to see how we'll navigate that. But in case you stop hearing me at any point, I deeply apologize for that. So today I'll be talking about building large sites on the Jamstack with on-demand builders. And what is that? On-demand builder is a new concept that's currently we're going first of all, let's start with the agenda that I did. So I'd like to start by about the Jamstack, trying to make sure that you understand what the Jamstack is and the challenges that large sites fit on the Jamstack, some popular solutions that have come up to solve those challenges, and then I'll introduce the on-demand builders approach to those problems. So what is the Jamstack? The Jamstack is not a stack. That's my term, I think, for the main stack or an alternative to the main stack or the LAMP stack and all of those things. The Jamstack actually is just a way of building or architecting the web where the UI is compiled, the front end is decoupled from all other services, and the data you need for the website is pulled in as it is needed. There are three major things that are important to note in this definition. And the first is that the UI is compiled ahead. The front end is decoupled and data is pulled in as it is needed. That is the definition of the Jamstack as of today, and we'll see more about that as we progress through this talk. So before we talk about what the Jamstack is, let's take a little bit, let's go back a little bit in time to what we used to have. Before we had monolith applications, where all the services that an application requires is built into that app as a single entity. Say, for instance, you have an application that has authorization, reporting, posts, database communications, comms, and all of those things. When they are all built together as a single app that is deployed as one single entity, that is what a monolith application looks like. And we were doing that until we
sorry for interrupting you, Ekene.
Identifying some challenges that you present.
Ekene,
One
sorry
of
for
being
interrupting
one single application. So that makes it kind of difficult to maintain because you could change something in one place and it will have a cascading effect all through your application, and you might break things in a lot of different places. Also, something that I found that is kind of challenging in monolithic applications is that it's not easy to for a remote team to work on monolithic apps, right? Because unlike some other architectures where somebody can own a different part of the application and do what they want with it and only communicate between different services, in monolithic applications, it's all coupled together. So if someone is working on something different, they could push a change that breaks something on what someone else in a different place is working on, and the communication and the back and forth between all of those can get really challenging. The last but not least is that it's just too many infrastructure to manage, right? If you're working on monolithic apps, you have to deal with things like databases, web servers, load balancers, all of those things that goes from not just development, but deployment and infrastructure is can be too challenging for somebody who is just a front-end engineer and just wants to write code, right? So out of all these challenges, we have microservices, which kind of like removes the same big one entity layer thing that we had in monolithic applications. Microservice created, gave us the opportunity to build applications where the services are not coupled together but talk to each other using APIs, right? So you can have an application that is just about authentication. You can have another application that is just about your posts. You can have another one about your comms, and they all talk to each other using APIs, removing the need to be coupled together and for things to break when you make changes in a different place. But like every other thing, it also had its own challenges because it requires a lot of experience and expertise. If you don't have good knowledge of how APIs work, you probably not do well when you're building microservices. So it requires a lot of experience in knowing how other things work and how services talk to each other before you can work on a microservice application. It also requires a lot more resources. It takes a lot much longer time to build because I mean, you're spreading out every part of your application into different microservices, and it takes a little bit longer to build than it would for a regular monolithic application. And that brings us to the Jamstack, right? All of these that we've talked about kind of, the Jamstack kind of adds a layer where all the sites or the communications or the different parts of your application comes together and gets deployed into a CDN where the site is now served to your users. So the layer you're seeing on top is not just like another architecture that we're adding on top of what already exists. It's just how you compile when you're done building your application, be it your monolithic app, be it your regular front-end application, be it your microservice, because Jamstack also allows you to work with microservices a lot. Actually, it's advisable because when static sites, if you're using static site generators in the Jamstack, you have the opportunity to connect it to other services like Auth0, Cloudinary for a lot of other third-party services that you might require in your application, which is advisable. But that's not all. This is also Jamstack, and yet this is also Jamstack. So at the end of the day, we build down to a static generator that bundles all of your sites, puts it in the CDN, and serves it to your users. So before we move further, let's look at how we deliver web applications. The first one is server-side rendering, right? In SSR, the majority of the work is done by the server, right? The browser sends a request for a page. The server computes and generates that page, and then sends it to the browser. The browser now renders the page to the user who requested for it. So all of the heavy lifting is done on the server side, which can, if you compare it to like server-side generation, you would see that you would probably spend a lot more time waiting for the server to produce that page, to send it back to the browser, to render it to the user. And that is why we wanted to go ahead and do SPA, so that we can change that functionality and give a lot more work to the browser. When we did that with SPAs, the issue is the browsers end up doing a lot of the work, and that also became challenging. But not just because the browsers are not at the time even capable of handling all of those kind of different functionalities, but it also depends on the power of the device that the user is using, which also now led us to what we have today, which is the Jamstack, right? The content is pre-built ahead of time. So when you finish building your application and you run your build command, all of your site is generated down to a file that is put on CDN and then served to your users. Let's see what this means. So the problem with that, well, one of the biggest problems with having a Jamstack site is that as it grows larger, your build time gets incredibly longer, right? Say, for instance, you have a site that has about 1,000 pages. Now, if you're building that site, the build time is going to get really high. And that is to be expected, right? Because if you have to generate about 1,000 or 2,000 or 3,000 product pages when your site is building, you can imagine how long it will take to make all of those API calls, to fetch all of those data, to generate all of those pages, and put them in all of the dynamic routes that you've specified in your application. So that has always been one of the biggest problems we've been trying to solve in the Jamstack community. And there's been some approaches that a lot of different companies and a lot of different people have tried to have come up with in an attempt to solve this problem. And one of them is right. This is something that the we and have all in try and solve the problem of long build times. For incremental builds, it just makes it possible for you to rebuild only the parts of your site that has changed when you make an update, right? Ordinarily, if you have a site with like 10,000 pages and you make an update in just one page, the default behavior is that all of the 10,000 pages are going to get regenerated, right? It's going to trigger a full site rebuild, and even the pages that doesn't have any new changes will also get regenerated, and that's not nice because, well, it takes a lot of time to rebuild all of those sites, and it costs you a lot more money because Jamstack sites, when your build times are going up, the cost you pay to your hosting providers is also going up. So that was a very good approach. That was a good solution to the problem of building your site every now and then and long build times. But the thing is that it doesn't solve for the initial long build time, right? What incremental builds helps you with is subsequent updates to your site, right? The every other existing doesn't have any changes as is, right? Which is great. But if you're deploying a new site and you have like 1,000, God knows how long pages, incremental builds don't do anything to help you with that. So you have to wait for all that long build hours to finish, and within a lot of people didn't like that, the fact that it has nothing, it doesn't help you with the initial long build times. So the next solution that came up in the community to solve this problem is incremental static regeneration, which basically builds most of your site as static site, some of your routes that you want to be generated at request time, right? A good example is, say you have a page of products and you have about 100 products. If you want to generate 10 products during build time, that is okay, so that your site can build really fast. Then subsequently on request, when users start asking for all of these other products, maybe the 11th product or the 12th product, then you can fetch that product. While that is going on, a fallback page will be displayed, and then the products will be generated and shown to your user. That way, you are also deferring some content to so that your build time is lower. You just build the critical pages that you need ahead of time, and then subsequently, when users are asking for other products that you didn't build that you didn't generate at build time, then you can subsequently generate them as the users request for them. But also, it has its own flaws, and which is that If you're using Next.js for this, you specify a revalidation timeline, which is the time where the content will be updated and new content will be generated. So pages can exist in different states during, before, or after revalidation, which can be a little bit tricky because different people in different places might get different versions of your site at a time. The next one is atomic and immutable deploys are hard to achieve, which are really good concepts that meet Jamstack what it is today, because you want to be able to instantly roll back to a different version of your site. You want to make sure that you're deploying an immutable state of your application at a time so that you can roll back to it. The ISR model kind of breaks that because you will not be able to keep a state, you will not be able to keep a part of your application that you're not updating at any point in time, right? If you're statically, if you're regenerating some pages and putting them into the bundle, then your site is no longer what it was when it was deployed. So you can roll back to any particular state of that site. The next one is that ISR is kind of specific because at the moment, it's only Next.js that has this feature that can do this. How do I solve it for long build times on the Jamstack? Another solution that has come up in the community is sharding, which basically means splitting your large sites into multiple independent microsites, right? This is something that I recently made a YouTube video about on how you can split your large Jamstack sites into multiple microsites. The idea basically is if I have a blog section with 1,000 blog posts, I have a documentation section with 200, 500 different documents on my blog. I have a products page and all of these different parts of my site that has made it really big and large. What I can do to solve that problem of large build times when all of those pages are being generated is to split them down into individual microsites that are not dependent on each other so that I can deploy them independently, and then I can use redirects and proxies to connect them together so that if I make any changes on my blog's site, my documentation and my homepage and my products page don't ever have to get rebuilt, right? Because they are not tied together in the same deploy. The problem with that is that you have to understand and implement some complex rules. If you're not familiar with directs, that might give you a little bit of time to figure things out. And also it requires regular maintenance because like if you have a products page, you have a blogs page, you have a docs page, chances are if you're working in a large company, those different sites are managed by a lot of different people and different teams. So you might require maintenance more often from people who are not working directly from your team. So that brings me to on-demand builders, which is what I'm here to talk about today. It's a concept that is recently introduced that is still in beta that helps you generate only critical pages at build time while you defer other pages until the first user request for them. So how does it work? With on-demand builders, you can split your site assets into two groups: critical pages and deferred pages. So the critical pages available at build time. Your homepage, your contact page, your about page, all those static pages in your site, and also the pages where you know that if somebody is coming to my website, this is probably where they are going to go first. You want to generate those pages at build time, and then subsequently defer every other part of your application that doesn't have to be generated, that is not critical to come up when the first user requests for it. A good example of this is is the example I used for the if you have a page with a site with 100 products, you want to maybe generate the first 10 products, right, and defer the subsequent 90 to wait until the first user has requested for them, right? It means that when your site is building, it's only going to build 10 products, right? Then it will defer the remaining 90 to not be generated during build time, but only when the first user has requested for them. So what happens is that when happens when the user requests for this page, build the on-demand builder file generates that page, put it in the CDN so that subsequent users who request for that page will get served from the CDN no longer, and the function will not run again. Meaning that after every first request on a site, on a page that wasn't generated at build time, all subsequent requests to that page will be served from the cache, and it will increase speed and it will lower your build times tremendously. So this is what a builder function, an on-demand builder looks like. You get it from Netlify functions. You define your asynchronous function that will generate the required content you want, and then you wrap it in a builder and export it. I'm going to. This is one of the next things I want to talk about in my YouTube channel. You should probably expect a content from me in about a month's time on this. But this is really good and it's really simple. As you can see, you just define your function, you put the logic that you want to use and generate the pages when the users request for them, and that's it. You're done. So what this means is that first, shorter build times mean that your whole team can be more productive and iterate faster. So if you can defer a lot of the pages, a lot of the content that would ordinarily mean you spend a lot of time waiting for your sites to build, if you can defer most of those things to when the users ask for them and just generate what the users need at their first visit, it means that your whole team can move a lot faster. Also, on-demand builders are very flexible and they can work across multiple frameworks. So unlike other solutions that are locking you into a particular framework or a particular language, on-demand builders is flexible and it works across, it's framework agnostic. So Nox users can do this, Next.js users can use this, 11t, Gridsome, Hugo, and the rest can all use serverless functions. Also, developers can now take advantage of caching for better performance, which is also something that ODB brings to the table. So the ideal case for this is an e-commerce site with thousands of pages or thousands of other pages to be fair and make sure your site is building ideally when at the lowest possible build time, right? Remember at the beginning I did mention that one of the core principles of the Jamstack is that you have to build as much, you have to build as much content as possible for your users. So if you're building a large e-commerce site and you want to get most of your products or certain categories that you feel will get you the most audience so that your users visit the most, you want to build all of that at build time and make sure that it's readily available. So ODB helps you make that happen. It will statically generate all of those pages that you specify and then use on-demand builders to fetch all of that subsequent pages and put them in CDN so that subsequent visits of those pages will be served from the cache. Also, dynamic applications that generate content based on user requests is also create something really nice, and I'm almost certain that will be ready tomorrow. And that is really nice. It's a very good use case because we are sending data from a form to a database, and then we're generating a page for that, and we're sending it back to the user. So that is an amazing application of on-demand builders as well that I'm really hoping that you all will play around with and help build your site in a much more efficient way. If you're publishing, or if you're building a site for publishing or for media sites, that's also a great use case for on-demand builders, and also for sites with user-generated content. I think I already talked about that. So I have some other useful resources that I've put on the slides. I'll share a link to the slides so that you can get these resources. This is a blog post and the documentation for on-demand builders that I think if you're interested in this and you're looking for ways or to learn more about on-demand builders and how they help you build better large sites on the Jamstack that has lower build times and also maintains all of the good advantages that you get from a Jamstack site, these resources will help you get that out of the way. So thank you once again. My name is Ekene Eze. You can find me on Twitter at Kenny_IO. And I'm looking forward to your questions.
Okay. Sorry, Ekene, I think we lost you for a moment there. It was a really interesting talk. And I can't wait to see what the future of the Jamstack holds. I think so many things are abstracted. As a developer, I don't really have to worry about most of the stuff. But saying this, well, I'm learning more than I did a few, let's say, 25 minutes ago. So really, thank you again for the awesome talk. Yes.
All right. Thank you very much for having me.
All right. Let's see if we have questions in the chat. It seems that it's a little silent and we don't have any.
All
But
right.
thank you again for
All
the
right.
session. It was a
Thank
pleasure
you.
having you.
Thank you very much for having me.
Okay, cool. Bye.